Okay, we are now in stoichiometry, okay? Essentially, what are we looking for here is we are looking and we're going to be working with moles, okay? If you did the course with me, we spent a lot of time going through this whole concept in depth, referring to cooking and baking and goodness knows what else we did. But essentially, what are we doing? We're looking for the mole. You always find the mole because that's the key to success here. I call it the mole hole for going through the chemical equations, okay? And it's the key to success. Question 18. Calculate the molar mass of the following and hence the number of moles in the mass given. So first of all, we are looking for something called molar mass, okay? And I abbreviated that to MM. It doesn't matter what you want to call it, but call it MM. Some people, generally, it's called M. Okay, I just did MM. Right, so what we've got here is molar mass. So how do we find the molar mass? They've given us a NH4Cl. How do we find the molar mass of the... What are we actually looking for? We're looking for the mass of the nitrogen, the hydrogens, and the chlorine all added together. The mass of all of the atoms. So the molar mass is the mass of all the atoms, correct? Together. And that's the mass per mole, isn't it? All right, let's have a look at these over here now. We've got ammonium chloride, okay? Right, let's have a look. Okay, the molar mass, right? The molar mass is equal to N plus 4 H's. There they are. NH4, 4 H's. Okay, let's just make you a bit prettier. I always do that, don't I? NH4. 4 hydrogen atoms and plus a chlorine atom. How much is nitrogen? 14 plus 4 times hydrogen is 1 plus 35.5. The molar mass of this, 53.5 grams per mole. Now, how do you write that? Well, you will see it as grams times mole to the minus 1 or grams per mole. I use both of those, okay? Just so that you get used to either way, all right? So what are we saying here? It's 53.5 grams per mole. Therefore, 1 mole is 53.5 grams, right? Now they have told us they want to know how many moles are there in 25 grams. And in number of moles is equal to mass over M, molar mass. I'm going to make that a capital M. Okay. I use molar mass or MM. Okay. Which is 25 grams divided by 53.5. My answer is 0.4673. Moles. Just have a look here. We took mass over molar mass, which is mass is grams divided by grams per mole. That is therefore equal to grams divided by grams per mole, which is equal to grams times mole over grams. And it gives me mole. For those of you going further in the sciences, that's quite a powerful tool that you're going to use in physics and chemistry in the future. Okay? Dimensional analysis. Right. Now, the next one is they say, calculate the molar mass of H2SO4. Right, so my molar mass is going to be 2 times hydrogen plus sulfur plus 4 times O. 2 times hydrogen is going to be 2 times 1, plus S was 32, plus 4 times 16, which is going to be 98 grams per mole, right? And the number of moles is mass over molar mass, which is 5 divided by 98, okay, which is 0.051 moles. I normally use 4 decimal places for these calcs, okay, because I think that gives sufficient accuracy. But please note, they will tell you what they want. Always, in physics and chem, they will tell you. Then they say potassium sulfate, K2SO4. Where does this 2 come from? Because minus 2 plus 1, so therefore we've got to have 2 atoms of potassium to link onto the SO4 minus 2 ion, correct? So let's have a look. Molar mass is 2 times K plus an S plus 4 times O. Okay? And of course, you know, on the periodic table, we're getting these from the atomic masses, right? On the periodic table. So if you look, for example, hydrogen is a 1. If you're ever in doubt which number, just remember chlorine is 35.5. It's kind of the odd man out. And you look and you see, that's where it is on my periodic table, 35.5, and you know it's bottom or top or wherever it is, that's the place where it is, and everything else from there is what you look for. Okay? Right, so let's have a look. So that's going to be 2 times potassium, 39, plus sulfur, 32, plus 4 times 16. And we end up with 174 grams per mole. And they want to know the number of moles given 10 grams is going to be 0.0575. Right? And the last one is going to be aluminium sulfate. Right. Now let's just practice again. This is D. This is D. And they say aluminium and sulfate. Let's practice putting them together again. Sulfate, minus 2. Aluminium, hang on, let's look across. You're there under B, boron. So you are a plus 3. You're a metal. You give away. So you're a plus. Therefore, minus 2. So that's going to be 2 to get that to a plus 6. And this one is going to be a 3 to get to a minus 6. Correct? So let's have a look. What is the molar mass? Is going to be, there's 2 times aluminium, right? Plus 3 times S plus 12 times O, which is 2 times aluminium, which is 27, plus 3 times sulfur, which is 32, plus 12 times oxygen is 16. Molar mass, 342 grams per mole. Therefore, number of moles is going to be M over molar mass, which is 20 over 342, which is 0.0585. Okay? So those are quite straightforward, and that's how we handle them, right? Let's have a look at now question 19. Calculate the concentrations of the following, right? So we're now talking about concentration. Concentration is C, and it's N over V, which is number of moles divided by volume. How do we measure the volume? Any takers? Yes. Decimeters cubed. And remember, 1 decimeter cubed is equal to 1 liter. Please, in chemistry, don't forget that. So our volume is always measured in decimeters cubed. Concentration, moles per cubic decimeter. Okay? let's go and have a look at some of these. Right. Calculate the concentration A. All right, A. So they say 15 grams of H3PO4 in 100 ml of H2O. Well, first of all, I have to get N. Always go for number of moles. That's where we're headed. So how do I get N? Well, first of all, I've got to work out the molar mass, haven't I? Molar mass of H3PO4, I've got to do it from here because otherwise it takes too long, and you guys have already done this, I hope. Right, so let's have a look. Molar mass is 3 times 1, which is the hydrogen, plus P is 31, plus 4 times 16. My molar mass is going to be 98 grams per mole. Okay, therefore N is going to be equal to 15 grams divided by 98. So my number of moles is 0.1531. Therefore, concentration is 0.1531. Whoa, hold on. Milliliters, liters, decimeters. Right. The first thing that I can advise you to do is, before you do anything, is convert milliliters, centiliters, liters, whatever you're given, to decimeters cubed. Convert it first off. Don't leave it. Because if you leave it, the chances are just get into the rote of converting everything in chemistry, decimeters cubed, right? Grams for moles, okay? The reason is, get into the habit of doing that, because in physics you're going to have to do the same. We're going to convert everything to kilograms, meters, and seconds. In chemistry, let's get the same process going. Get the conversion straight away into what? Decimeters cubed. Yep. So that's where we've got to go. So we're heading for decimeters cubed. How do I do this? Well, I've got 100 milliliters. Oh, hang on. Remember when we started off with that table, the Kilimanjaro that I had there, right? If you're going up, you do this. So where are we? We're at milliliters, centiliters, deciliters, okay? And that's terrible, liter. But let's just say, and liters. So I've got 100 mil. I am starting here and I'm going up. Therefore, I must divide. Divide by 1, 2, divide by 10, by 10, by 10. That's 1,000. So it's going to be 10, 100, 1,000 is 0.1 liter. That is 0.1 decimeters cubed. So I convert this straight away to 0.1 decimeters cubed. Why? Because then I won't forget it in my calculation, because I've got to put that over, where are we? All right. Concentration is going to be, okay. Oh, sorry, is 0.1, yes. Okay, so my concentration comes to 1.531, 1,531 moles per decimeter cubed. And yes, the moles per decimeter cubed is critical, because in grade 11 and 12, we're going to be using concentrations a lot in equilibrium chemistry. Concentrations are going to change, rates of reactions, etc. That comes in later. How fast things happen. In other words, how fast does the concentration grow? Things you need to know, especially if you're taking an antibiotic. You want to know how fast the concentration in your blood rises, don't you? Okay, the next one is 21 grams in 250 ml of sodium chloride. All right, so let's have a look. Okay, and we say, right, this was B. All right, so we've got 21 grams NaCl in 250 ml. What do we do first? We convert. Okay, I'm going to do it in red. Convert This is basically, we're just going to divide by 1,000 is 0.25 decimeters cubed, because we've gone up the liter and across, right? Okay. If you're battling with this, please go back and do a few. Go to that table that I started off with, the very first introductory lecture, okay, where we do this table of conversions. All right. Next we said, right, now we do molar mass. Is going to be 23 plus 35.5. Sodium and chlorine gives us 58.5 grams per mole. Okay, therefore N is going to be equal to what mass? 21 over 58.5 is equal to 0.3590. Okay, moles. Therefore, concentration is 0.3590 divided by, in this case, my 0.25, and the answer is going to be 1.436 moles per cubic decimeter. Okay, now let's have a look at number C. Okay, let's look at C. Question C is ammonium nitrate, NH4NO3. Okay, and 15 grams in 20 centiliters. In 20 centiliters. Okay, well, how do we go about this one? Same, always when in doubt, find moles, right? So let's go for molar mass. Molar mass of this is going to be 14 plus 4 times 1 plus 14 plus 3 times 16. Okay? Please, when you do this, don't just try and bang it all out on a calculator. Just be careful. It's actually worth the respect of doing it, instead of just trying to put it in a calculator and making a silly mistake, and then everything is wrong, and you knew exactly what to do, but it was a silly error with regard to a calculation. Okay, the molar mass is going to be 80 grams per mole. Okay, if the calcs that I've done are right. Therefore, N is going to be mass over molar mass is going to be 15 over 80. Okay. Right, 15 over 80, and let's just check, and we say 15 divided by 80 is going to be equal to 0.1875 moles. What didn't I do? I didn't convert. So the chances are in a test or an exam, I'm going to put 20 centiliters underneath there because, hey, it looks okay. No. So we say, right, milliliters, centiliters, deciliters, liters. I am here with 20. So I'm now going to go up 1, 2. So I must divide, because I'm getting smaller, by 10 times 10. 1, 2. It's 0.2 liters, which is 0.2 decimeters cubed. Therefore, I'm getting a bit ahead of myself. Therefore, concentration is 0.1875 divided by 0.2. And the final answer is 0.9375. Moles, decimeters cubed, like that, right? Okay, right. Now, let's have a look at question 20. All right. Question 20 is where we're talking about, let me get to my question 20 here. Question 20, they say, given the following, calculate the mass of gas, all right? Now, we're kind of going to get into things called STP, but let's just have a look first. First of all, let's have a look. Okay, this is question 20, correct? Question 20 says, okay, let's have a look here. Find the mass of the gas if I've got 0.05 moles of H2. Right? Okay. Now we've got moles and we want mass. So therefore, always let's look molar mass, molecular mass. Okay, of hydrogen is 2 times 1 is equal to 2 grams per mole. Oops, yeah, mole minus 1. Remember the formula? N is equal to mass over molar mass. All right, so if I've got N and molar mass, I can work out mass. Is N times molar mass, which is 0.05 times 2. Okay, 0.05 times 2 is 0.1 grams. Okay, 0.1 grams of H2. All right, it's quite a small amount. All right. Question B. Let's have a look at question B. Question B says 5.32. Question B says 5.32 decimeters cubed of CO2 gas at STP. Okay. What's so special? STP, standard temperature pressure. Those of you who did this course with me know this straight away is a trigger point. Okay? Straight away, STP makes me say 1 mole of any gas is 22.4 cubic decimeters. Okay? Straight away I say that because I see the words STP involved with the gas, obviously, all right? But that's where it is in this case. So we say, right, I have got 5.32, okay, decimeters cubed. So what do? Underneath, we put in what we know. 5.32 decimeters cubed. We need to know how many moles, or what's the mass, okay? So we've got to get to moles. Always getting to moles, right? Unless moles are given, right? Then we're going to be working out something else. So what do? We want to work out moles. Always get there. So X moles, how do I solve this? Okay. Basically, obviously, it's cross multiply. So the final reckoning is 22.4 X equals 5,32. Therefore, X is 5,32 divided by 22.4. Okay? And 5,32 divided by 2, where are we? 20 is 0.2375. Hope everybody's with me there. If you've done these with me in the sessions, you'll see that's what we do. We cross multiply, right? We put down what we're given, 1 mole, 22.4, and then if we're given moles or given decimeters cubed, the one we don't know we call X, and we cross multiply to find out what X is, either moles or decimeters cubed. Right, so therefore now X is that, and here it's going to be moles. Therefore, we have 0.2375 moles of CO2 gas. What's the next step? Okay, straightforward. The next step is work out the molar mass of CO2. And the molar mass of CO2 is going to be 12 plus 2 times 16, which is going to be 44 grams per mole. Now I know, hang on, N is equal to mass over molar mass. Hang on, we know that and we know that. Therefore, mass of CO2 is going to be number of moles we've worked out, 0.2375 times 44. And the final answer is 10.45 grams. Okay. Let's do the next one. They said to us, 32 decimeters cubed of O2 on C, 32 decimeters cubed of O2 at STP. Okay, straightforward. Trigger. Straight away, 1 mole is 22.4 decimeters cubed. Write down what we're given, 32x cross multiply. Okay, and what do we get? 22.4x must be equal to 32. So x is 32 divided by 22.4. And your answer over here is going to be equal to it's 1.429 moles of oxygen, right? Okay. Now, we don't want moles, we want mass. So therefore, we've got to go for molecular mass of O2 is 2 times 16. Please don't forget that. A lot of students forget that too. It's a diatomic. Oxygen on its own in the element table, right, is 16, and we got 2 of them, so it's 32 grams per mole. So therefore, 32 grams per mole, right? What do we do next? We say, N is equal to mass over molar mass, so therefore I can work out the mass. Is going to be N 1.429 multiplied by 32, and my final answer is going to be 45.71 grams. Okay, pretty straightforward. Okay, those are not too difficult ones. Okay, we've got to the end of question 20. All right. Please, when you go through these things, okay, you've got the questions in front. Go through, take down what I've done, and then go back over it. Okay, just check the steps as we go. Get those steps into your processes of doing it. The quicker you just go through the steps of the recipes, all right, the easier and the less effort you actually have to put in to studying chemistry. The same goes for physics, really. Okay, maths the same. All 3 of these subjects, all right. But with chemistry specifically, this part, the stoichiometry, it's usually done right at the end of the year. It's gone through very quickly, and in grade 11, a lot of students I'm with, we have to do quite a lot of revision catch up. Okay, so but the stoichiometry is actually not really that difficult, because what we're going to do is when we start looking at the equations, I'm going to do tables with you. All right, we're going to do it in a table format. Cheers. Thanks for watching that one. Next, we're going to carry on with stoichiometry. We're going to carry on with the next question, starting at question 21. Thanks. Cheers. Have a great time. Bye.